Okay, section 7.2 in your notes here. I am towards the bottom of page 4 in your notes. Towards the bottom of page 4 dealing with section 7.2. This is going to be split into several videos just because of the length of this section. Here's a little warm-up exercises from last chapter, making sure this is dealing with the video 6.1 exponents, making sure that we can simplify things like this when they are integer exponents. Then we're going to get into rational exponents. So, first of all, these are the same base. 4 and 4 are the same. You can add those powers together to get 4 to the negative 2. Negative powers mean you put them on the bottom, so you end up with 1 over 4 squared, which is 1 over 16. Here, we call this a power to a power because the exponents are right next to each other. There's no 4 or anything else in the way. So when you have a power to a power, you multiply these to get you 2 to the 6th. Here, which, by the way, if you were to multiply that out, I suppose is somewhere around 64. Here, when you have the same base here, when you have a 3 and a 3, you can subtract these exponents to get you 3 squared, because 4 minus 2 is 3. That simplifies down to 9. And the last one, again, making sure negative exponents go on the bottom. 1 over 2 to the third, 1 over 8. 2 times 3 to the fourth. We are going to distribute this fourth in there. You'll see why here in a minute. But I end up with 2 to the fourth times 3 to the fourth. 2 to the fourth is 16. 3 to the fourth is 81. Put those two together, and you will get...
Seniors, this is a reminder you need to turn your...
Thank you for that lovely disturbance, but you should get right around 1296. Warm-up exercises. Okay. This little sentence right here is talking about simplest form of radicals. What this sentence helps you to determine is, are you done with the problem yet? Because that is a common question from a lot of kids. Mr. Palmer, when am I done? How do I know I'm done? When am I done with this one? Well, here's how you can tell. If you have a radical expression, meaning the square root or the third root or something like that, after you apply all these properties we're going to talk about of radicals, you've removed any perfect powers, which we're going to talk about in this list down here. That's going to be this list. And you have rationalized any denominator. Then you are officially done and you can't simplify it anymore. So let's take a look, starting with these perfect squares. Let's take a look at how we're going to make this list right here together. First of all, we're going to add 2 columns to this. I'm going to put the number over here, and the 5th also over here. This is going to, from here on out, be known as the list. I'm going to refer back to the list constantly. So when I do, you're going to want to get your list out. I'm not going to constantly flip back because I know the list, but you are going to want to refer back to this whenever I talk about it. So let's start with the number 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And we're going to add 2 to the fifth, which is 32. We are going to make this list for 2, 3, 4, 5, 6, 7, 8, and 9. But we're going to cross off some of this 5th stuff because that's not real helpful. When we get there, I'll show you what I mean, but let's start generating this list. Starting with 3. 3 squared is 9. 3 to the third is 27. And 3 to the fourth is 81. And 3 to the fifth is 243. Same thing with 4. You can see where I'm developing this list, so we're just going to go a little bit faster here. 64 times 4, I believe will get you 256. And 4 to the 5th is 1024. After this, you really don't need to worry so much about this 5th power anymore. After you get past 4, you won't have to mess with any numbers bigger than 1024. 5 squared, 25. 125. 625, and don't worry about that last one. 6 squared is 36. 216, and 6 to the fourth is 1296. Same thing, after you get into the thousands here, you won't have to worry about this one so much. 7 squared is 49. I believe 7 to the third is 243. Let me check. 343, sorry. 7 to the third is 343, and you won't have to worry about the fourth. 8 squared is 64. And 8 to the third is 512. Do the same thing for 9, and we'll be done with our list. 9 to the third is 729. I'm going to come back to this list quite a bit, so make sure you have yours handy. I told several of you in class to make sure you put a star by this so you come back. Okay, go ahead and flip it over and we'll get going talking with some examples. Knowing all of this, here are some properties we're going to use. Notice all of these properties going down this page in your notes are all the exact same thing as the properties in the last chapter, except now we're going to be dealing with fractions instead of just plain old integers. So all of these are still the exact same properties. We're just going to use them in a different way. So if you have the same base here, a to the m, a to the n, you keep the base and you add these exponents, a to the m plus n. So 3 to the 1/2 times 3 to the 3/2, you add those fractions, and remember adding fractions you have to have common denominators. They already do, so this ends up being 3 to the 4/2, which is 3 squared, which is 9. Power to a power, same concept as before. You multiply these, you keep the base to be a to the m times n. So I'm going to multiply these two things, 4 to the 3/2 times 2 over 1. You can cancel these 2's out. It ends up being 4 to the third, which now we know is 64. B to the m. I'm going to distribute this m in there. So you end up with a to the m, b to the m. Same thing here. I'm going to end up with 9 to the 1/2, 4 to the 1/2. The 1/2 power, if you remember from the previous video, is simply the square root. So this is the square root of 9 square root of 4, which is 3 times 2, which is 6. One thing that you can note as well on this property, not only can you split these up by distributing the m in there, but also you can put them together as long as this and this are the same. If these two powers are the same, then you can go backwards and multiply the numbers and just simply put it to the m power. What do I mean? I mean if you were to have like 3 squared times 4 squared, because these two are both to the same power, that's the same thing as 3 times 4 squared, which is 12 squared, which is 144. You can do that. You can go forwards and backwards with this property. Moving on down the list. Negative powers we know you put on the bottom, so it's 1 over a to the m. So I'm going to put this one on the bottom, 1 over 25 to the 1/2. Remember, 1/2 is square root. Square root of 25 is 5, so that becomes 1/5. Power over a power. As long as this a and this a are the same, you subtract them, a to the m minus n. So I'm going to go 6 to the 5/2 minus 1/2. In order to subtract fractions, they have to have common denominators. They already do, so you end up with 6 to the 4/2. Reducing that, you will get 6 squared, which is 36. And to finish up, distribute this m in there. You end up with a to the m over b to the m. So I'm going to put this 1/3 into 8, so I get 8 to the 1/3, all over 27 to the 1/3. Since 1/2 is square root up here, 1/2 is square root, 1/3 is the cube root. If you refer back to your list, the cube root of 8 is 2, the cube root of 27 is 3. This rule also applies backwards, meaning if you had two different bases to the same power, you can put them together. Like if I had 4 to the 1/3 all over 6 to the 1/3, I can put these together to be 4 over 6 to the 1/3. So not only can you split them, but you can also put them together. 2/3 to the 1/3. That is legal. So let's take a look at some examples. Right here up at the top of page 6 in your notes. We're going to try these examples and I'm going to give you some to try on your own. So using these properties, taking a look at letter A here, these have the same base. So since they both have the same base, I can add these exponents. So I'll end up with 5 to the 1/2 plus 1/4. And to get common denominators, you're going to make those both into 4s. So it's 2 over 4 plus 1 over 4, which is 3 over 4. So your final answer here is 5 to the 3/4. And you can leave it just like that, because you can't simplify anything else, and you don't know what the 4th root of 5 is. Same thing here. These, I'm going to distribute the 2 in here using our power rules here. That means I'm going to multiply. So I end up with 8 to the 2 times 1/2 and times 5 to the 1/3 times 2. 8 to the 1/2 times 2 just becomes 8 to the 1. And this becomes 5 to the 2/3. And you can just leave it like that because this and this aren't the same, meaning the bases aren't the same, and neither are the exponents. So if the bases and the exponents aren't the same, there's nothing else you can simplify. Over here, I'm going to distribute that -1/4 in there. So I will end up with 2, this is a multiplication, 2 to the -1 times 3 to the -1. 2 to the -1, 3 to the -1, they're both negatives, so that means you're going to put them both on the bottom. 1 over 2 times 3, which is 1 over 6. Let's grab a different color here. These are being divided. Because these bases are the same, you are going to subtract these exponents. So you're going to end up with 7 to the 1 minus 1/3. And 1 minus 1/3, if you get common denominators, is 2/3. 7 to the 2/3. And the last one. We have a couple choices here. I'm going to show you maybe the easier way to do this. I'm going to take this 2 and distribute it in there. It is a power to a power because they're right next to each other, so I'm going to multiply those exponents. So I end up with 12 to the 2/3 over 4 to the 2/3. Because, this is the fun part, because this 2/3 and this 2/3 are the same, even though this 12 and 4 aren't the same, I can put those together as 12 over 4 and put it all to the 2/3, only because these are the same. And I can reduce 12 over 4 to be 3, and I end up with 3 to the 2/3 power. Done. So there's some examples on how to work with fractional exponents. What we're going to take a look at in the next video is using fractional exponents. We're going to turn them into radicals, and we're going to work with that. So right now, that's where we're headed.